Hello, my name is Takao Futagami. In the last xtUML day in UK in 2019, I explained about xtUML activity in Japan. In my presentation, one big success of multifunction copier machine development was introduced. Mr. Tsuchitoi was taking major role as MDD modeler as well as architect for BridgePoint-based software development in Fuji Xerox Corporation. He's also taking UML ET Robot Contest in Chief as model judge. I also explained another contest called MDD Robot Challenge, where people fly model blimps. Dr. Hisazumi has been kindly working with academic members for this challenge contest. Since I created those contests years ago, they have been improved every year, led by capable guys like Tsuchitoi and Hisazumi. Today, you will see what kind of BridgePoint-based online xtUML education is prepared for youngsters in Asia by those gentlemen. Please enjoy their talk.
Hello, I'm Yuki Sato from Japan. I'm a member of Executive Committee of ET Robocon for 6 years. And I'm a chairperson of xtUML JP, a user group of xtUML in Japan. I'm glad to speak here today. Thank you. Today, I'd like to introduce ET Robocon, a robot contest for educating software engineers. I would be glad if you know about ET Robocon and be interested in our activities. And as an activity of xtUML we made a model compiler for the robot and simulator environment. I will introduce it too. Okay, I'd like to start by showing a video of ET Robocon. Okay, can you imagine ET Robocon race? But ET Robocon is not just a robot contest. The goal is to educate software engineers, especially embedded software engineers, to learn modeling. This contest started in 2002. The first motivation was to popularize UML to Japan. So it was called UML Robocon at the time. And it was a very small contest, but nowadays we had 259 teams and over 1,000 people participated last year. Participating teams are not only company employees, but also students, from high school to college. Actually, half of teams are students' teams. This contest has several characteristics for learning model effectively. The one of them is the robot. We use Lego Mindstorms for robot, and all teams uses the same construction robot. This means that robot has no physical differences. The robot performance is determined only by software. And the most important characteristics is model evaluation. Participating teams submit the models as model sheets before the competition. Judge member evaluate the model sheets and score them as evaluation result and make feedbacks for them. The total result of a team is determined by not only race, but also model evaluation result. In this regulation, participants must learn and use models. xtRobocon is a sandbox for modeling. Next, I'd like to explain about the robot we are using and the software platform. The robot is made of Lego Mindstorm EV3. Yep. EV3 is a programmable brick and various options like motors and sensors are connected. We can build various robots using Lego parts. And EV3RT is a platform to develop and run program on EV3. The OS is microitron-based real-time OS. You can control the motors and sensors in C or C++ programs. Participants basically use this environment for creating their robots. xtRobocon provides some educational materials and lectures for beginners of EV3RT and modeling. Now, I'd like to move on to talk about modeling evaluation. As I mentioned, participants must submit their model sheets about 3 or 4 weeks before competition. The model sheets consist of 6 sheets in A3 size. And we have 2 classes according to the participant level. The one is primary class. Primary class is for beginners of software and modeling. The rule is simpler and easier. Advanced class is for intermediate level and the rule is more complex and difficult than primary class. This figure shows the image of one of the subjects of advanced class. Robot moves blocks, these are blocks, to same color circles. For example, this is a blue block and robot moves on these blue circles and make Bing in max 4 lines. 1, 2, 3, 4. So robot must direct the route to move the blocks and make Bing and clear this game. The advanced class model sheets include these kinds of models. By this, we intend participants to experience a series of modeling. So let's see actual models quickly. This is a requirement model. This page shows the goals of teams and quality requirement derived from the goal, using such as GSN or requirement diagram. Next, this page states analysis model. Participants analyze the rule of the game and make resolution by using model. Sorry for Japanese model, but this model class model has information like root and current block positions and the colors and the connection of lines and so on. This page shows design model to implement the system as codes. We evaluate design policy and the structure, behavior, and so on. This page is a last page, shows control models. It may be not the models, but we evaluate the ideas and the inventions to improve their quality and the realities of them. Last year, as we provide camera system to capture course conditions, many teams tried to analyze the image to detect blocks position and the colors. This team also describes the method how to detect the blocks and colors. Now, let's turn to talk about total result. We normalize race results between teams. Here, from 0 to 1. Model evaluation results are also normalized in the same way. Here, finally, we calculate the harmony means. This is a distribution of 2019's advanced class finalist teams. Right upper position is better rate. You might note that this figure shows correlation between race result and model results. This is not from the beginning of ET Robocon. There was no correlation between them. There were a lot of teams which had good race result, but bad models. That kind of model was placed here, and vice versa, was shown here. The main subject of the race at the time was how to control robot better. So parameter tuning was the most important and the model effect was relatively low. It is getting better after we provide complex game like block bingo since 4 years ago. Like this, we are improving ET Robocon to be better modeling learning platform. Next, I'd like to tell about 2020 situation. Unfortunately, we can't hold a real contest this year because of COVID-19. So ET Robocon 2020 is held using a simulator environment. I'd like to show you the video of the simulator. Okay, how was that? This environment is based on Hakonia platform, which was made by Japanese organization Topaz. By using CPU emulator, we call this ASRI. We can use the same program for simulator as the real robot. As program environment is the same, model sheets are also required this year. This simulator environment can be used by everyone, but there are some limitations. Only participants can use actual course. for of the competition. Instead, we provide sample course. The sample course can be used by everyone. And another limitation is currently the instructions of this simulator are written in Japanese only. So we will translate them before long. This is the last slide for my part. This is not related ET-Robocon directory, but as xtUML JP activity, we made the model compiler for LEGO Mindstorms. You can create robot program by creating models on BridgePoint and generating source code from it. It works for both simulation and real robot. Currently, it is experimental and under testing, but please let me know if you have interest in this environment. That's all I have to say. Thank you for your attention.
Hello, my name is Kenji Hisazumi from Kyushu University. Also, I'm one of the co-chairs of the April's Robot Challenge. Today, I'd like to talk about the April's Robot Challenge. In this challenge, we educate modeling using xtUML and Marriagecopter. This slide shows overview of April's Robot Challenge. This challenge is collocated event of April's since 2018. Objectives of Robot Challenge is educate the IoT robotic system engineers. These engineers should have interdisciplinary skills like software engineering, electrical engineering, and mechanical engineering. These engineers required to draw the models. And for the softwares, we employ xtUML. Also, students can conduct international project-based learning. Actually, we have a long history in Japan. We conducted a ESS Robot Challenge since 2024. Firstly, we employed airships for the PBL target. After that, we changed the target to the robot cleaners, small robot, and etc. But we believe that it's important to use the attractive development target. Last year, we held on the April's Robot Challenge in Pattaya, Thailand. We employ this Marriagecopter for the development target. This Marriagecopter is so easy to use and attractive for students. This is the course of the last year. The mission is to take all of the picture of the fruits in the greenhouse. So the Marriagecopter fly into the greenhouse and take all of the fruits and go back to the original position. These are the pictures of the last year. So they draw the requirement like this, and they implement it with the BridgePoint. We held on this challenge such a beautiful area, but we cannot conduct this challenge in face-to-face in this COVID-19 situation. So we met some challenges like no face-to-face lectures, hands-on labs, and project-based learning. Also, we cannot use real machines. But now we have opportunities to have a skill for work from home or distributed work. Also, we can get a skill to use virtualization technologies. So this year, we introduce remote communication tools and a modern development environment, and also Marriagecopter simulator. This year, we provide this Marriagecopter simulator environment to the challengers. This environment provided as a Docker image. This image includes a robot operating system, ROS, and Marriagecopter simulator, physics engines, and BridgePoint. Student develops the autonomous controlling system for this Marriagecopter. Student draws the class diagram and state machine diagram to control this Marriagecopter in this simulator. This is the structure of the software. Here is the physics engine Gazebo, and it's connected to the Marriagecopter simulator. Marriagecopter simulator connected to the generated code from the xtUML. Actually, this connection using a robot operating system protocol. We provide a handwritten bridge to speak or to this command. This bridge provides an interface to control the Marriagecopter, like a takeoff, land, and set destination, set heading, etc. So, students develop this component to control this Marriagecopter. In these 2 years, we use xtUML and Marriagecopter to educator modeling. We believe that xtUML and Marriagecopters attract students' interest because students can get a quick feedback from execution results. It's from code generations using model compiler. Also, it's easy to keep motivation for the students. Students bored or afraid of writing non-executable model because of the result, they cannot get the result immediately. Let me share the result of our trial in Japan. This is a demo video, and our student develops this system. The system for surveying disaster sites. This Marriagecopter fly into these disaster sites and find survivors. Actually, this system not fully automated, but so student manually control this Marriagecopter. But they developed to support to control this Marriagecopter like this. They called HUD, head-up display. And this Marriagecopter can easily find survivors in need help, like this. And a little bit skip them. And this Marriagecopter go back to the original position. Thank you for listening. If you have any questions, please feel free to ask them.